today we are working on lesson 7.3, page 221, solve a variety of percent problems. Right, and the learning target today is I can write a percent as a fraction or a decimal and use a variety of strategies to solve real world problems. Liz is collecting aluminum cans for a school fundraiser. So far, she has collected 16 cans, which is 20% of her goal. How many cans must she collect to reach her goal? So part A, use a double number line to solve the problem. When Liz reaches 100%, she has reached her goal. Complete the double number line until you reach 100%. So we can go ahead and take a look at the double number line. On the top number line, we have cans, and this is counting by 16. So this will be 0, 16. Then you continue adding 16, 32, 48, 64, and 80. And then we count our percentage number line by 20%. So 0%, 20%, 40%, 60%, 80%, and 100%. So for every 16 cans Liz collects, she adds 20% toward her goal. If she reaches 40% of her goal, she will have how many cans? 32 cans. So Liz must collect 80 cans to reach her goal of 100%. Number 2, Jose is in the same class as Liz, and he is also collecting aluminum cans. He has collected 36 cans, which is 18% of his goal. How many cans must Jose collect to reach his goal? Use equivalent ratios to solve the problem. One ratio is the percent, 18 over 100. The second ratio is the number of cans already collected compared to the total number of cans that must be collected. You know the first number, the part of the ratio, so you must find the second number, the whole of the ratio. Then complete the ratio. The gray box represents the unknown number. So we know that he already has collected 36 cans, okay, and that is 18% of his goal. So he has collected 36, but we don't know what his goal is yet. So we're going to use an equivalent ratio to help us to set this up. So we know that 18%, he has collected 18% of his goal. So 18% can also be written as 18 over 100. And we know that he has collected 36 cans, which is 18% of his goal. So we'll write the 36 in our numerator. Okay. Then we want to look for patterns, and we notice that 18 is multiplied by 2 to get his 36. So we just noticed that relationship there. So remembering that in order to be equal, whatever is done to the numerator must also be done to the denominator. We multiply 100 by the same amount to find the answer. So 100 times 2 will give us 200. So Jose must collect 200 cans to reach his goal. Okay, let's turn to page 222. Oh, and a discussion point is, so we can pause for discussion here. Which method do you think is easier to use, a double number line or finding equivalent ratios? And then explain which way you prefer and why. Okay, so let's go to the top of page 222. And we are looking at, in Big Bog, Maui, Hawaii, about 400 inches of rain falls during a normal year. It is the 7th wettest place in the world, judging by annual rainfall. If 364 inches of rain have fallen so far, and you expect the rainfall to reach the usual yearly amount, what percent of the year's rain has already fallen? Use equivalent ratios to find a solution. So part A, you already know, you know one ratio already, the rainfall so far and the total amount of rainfall expected. Write the ratio in fraction form. So we know that 364 inches have fallen already, and we know the usual rainfall is 400 inches. So we can write this in fraction form. 364 is our numerator and 400 is our denominator. And then the ratio that we need to solve for is the percent. Okay, this time we do know the expected rainfall, 400 inches, and the rainfall already received, 364 inches. So 360, and we have a very nice visual over here, 364 inches so far, and 400 inches expected yearly in Big Bog, Maui, Hawaii. So we want to find our equivalent ratio. So we'll start with the ratio that we have complete, 364 inches already fallen out of 400, and we want to change that to a percent. Remember, percent means per 100, percent. Remember, we can help to remember this by remembering there are 100 cents in a dollar, there are 100 centimeters in a meter, there are 100 years in a century. So percent means per 100. So we notice to get from our denominator of 400 to our denominator of 100, we can divide by 4. And so we would want to apply that same division to our numerator to get our answer. So we would do 364 divided by 4. Okay, 4 too big to go into 3, so we cannot write anything above the 3. 4 can go into 36 9 times, so we write the 9 above the 6 into 36. 9 times 4 is 36. So we subtract 36 minus 36 is 0. Bring down our 4. There's our arrow. 4 goes into 4 one time. 1 times 4 is 4. 4 minus 4 is 0. We have no remainder, and there's nothing else to bring down, so we know we're finished with our division problem. So we have, this will be 91% according to our long division problem. So if we look at letter D, I know there's a little lag on our camera. Sorry about that. But 400, if we read along with letter D, 400 is divided by 4 to get 100. So we would need to divide 364 by the same number. To find the percent, 364 divided by 4 equals 91. Okay, and we did that over here with our long division problem. So this tells us that 91% of the annual rainfall has already fallen. So 91% of the annual rain has fallen so far. So turn and talk. How did you know which ratio to find? I'll pause the recording while we do that turn and talk. And we want to, so we're looking at the percent or the inches of rain. So how did you know which ratio to find? In a city election, 5,000 people voted for mayor. If the new mayor received 60% of the vote, how many people voted for the new mayor? Show how you know. So we know that we can set up a proportion here. We know that 60% of the voters voted for the new mayor. So we can write the 60% as 60 over 100. And we know that 5,000 people voted for the new mayor, or excuse me, 5,000 people voted for mayor. So let's read carefully there. That's the total. 5,000 people voted. So out of those 5,000, we want to know how many voted for the new mayor. And so we want to go from 60% to what is 60% of 5,000. So we look at our whole, which was 5,000 voters altogether. That's our 100%. And want to know what can I multiply 100 by to get to 5,000. So what we can do is we can work backwards. We can do 5,000 divided by 100, which to divide by 100, we can move our decimal 2 places to the right and know that that will be 50. So to get from 100 to 5,000, we need to multiply by 50. Okay. So we know that we multiplied our denominator by 50. So we also need to multiply our numerator by 50. So whatever I did in my denominator times 50, I need to do to my numerator times 50. And so 6 times 5 is 30. And then it wasn't 6 and 5, it was 60 and 50. So add this 0, which is times 10, and this 0, another times 10. So 3,000 people voted for the new mayor. And then moving on to number 2. At the King School, 55% of the students take a bus to school. If 220 students take a bus to school, how many students are there in total? So we know that 55% of students take the bus. So we can express that as 55 over 100. And then we know that there are 220 students who take the bus. We want to know what the total is going to be. So I want to know how many times 55 can go into 220. So I know 55 doubled would be 110. And then if I doubled that, it would be 220. So this is going to go in 4 times. And you can check that with long division if you wish, but 220 divided by 55 would give you 4. So 55 times 4 gives us 220. So we need to do that same thing to our denominator times 4 to get 400. So 400 students, there are 400 students in total. Okay, number 3, when Randy is 3 years old, the doctor tells his parents that Randy will be 180 centimeters tall when he is fully grown. If Randy is 90 centimeters tall now, what percent of his expected adult height is he now? So we know he's already 90 centimeters tall, and his predicted height is 180 centimeters. So he is 90 out of his predicted 180 centimeters tall. And then they are asking us what percent is per 100. So out of 100, how far is he to his expected total adult height? We know notice the relationship between 90 and 180 as a times 2. 90 is half of 180. So this is 50 out of 100. 50 per 100 is 50%. So he's 50% of his expected adult height. Number 4, on a math test, Janice answers 85% of the questions correctly. If she answered 17 questions correctly, how many questions are on the test? So 85% was her score. And she got 17 correct there. Okay. So we want to look at the relationship between 85 and 17. I kind of think of it this way. I'm thinking, well, 17 times what will give me 85. I'm rounding that up to, let's try 5 or 6 here. So I'm just going to do a little guess and check. I think it's 5. So 17 times 5. 5 times 7 is 35. Right, the 5, carry the 3. This is looking good. 5 times 1 is 5, plus the 3 we carried is 85. If this weren't correct, we would continue to guess and check until we have the correct answer. So to get from 17 to 85, I multiplied by 5. So to go the other way, from 100 to my answer, I need to divide by 5. Okay, just to clarify, to get from 17 to 5, I multiplied by 5 from right to left. So if I'm moving left to right, 100% down to the actual number of questions, I need to do the inverse operation. The inverse of multiplying by 5 is divide by 5. So this is 20, which means there were 20 questions on the test. Okay, so this was Module 7, Lesson 3, and we were looking at solving a variety of percent problems. Our learning target again, our learning target today was I can write a percent as a fraction or a decimal and use a variety of strategies to solve real world problems. Okay, great job today, 6th graders.